So example 5 is a bit different, if only because there's no picture. It says, if a triangle has side lengths of 4, 4, and 4 square root 2, is the triangle a right triangle? So this is our ultimate question is, can you take those lengths and force them into a right triangle, or are they just some other type of triangle? Your test for that, the reason why it's in this lesson, is it Pythagorean theorem. The Pythagorean theorem only applies to right triangles. So if the Pythagorean theorem works, then it's a right triangle. So when it says, is the triangle a right triangle, what we're really asking is, does the Pythagorean theorem, now I say work, basically, do you end up having the same thing on both sides? So let me show you what I mean by that. The Pythagorean theorem, a squared plus b squared equals c squared. It's supposed to be equal on both sides, so if it's not, that's when you'd say, hey, that's not a right triangle. But it matters where you put in your lengths. Now, if I ask you what number is bigger, 4, 4, or 4 square root 2, well, clearly 4 can't be the biggest because 4 is the same as it. But if you're really not sure if 4 square root 2 is bigger, you could always type that in your calculator. It's going to be bigger than 4. And the reason I care about that is the hypotenuse, or the potential hypotenuse, has to be the longest side length. So if I'm trying to figure out, well, where do I put these three numbers? The longest side length goes in for C, which means the A and the B, the legs, would have to be the 4 and the 4 if it's a right triangle. And the hypotenuse would have to be the 4 square root 2 if it's a right triangle. So if it's a right triangle, I'm going to get some number equals the exact same number. If it's not a right triangle, I would get some number is not equal to something. So like 7 equals 150, or just two things that are not equal. That's how we can tell whether we've passed this test or not. So I'm going to start by squaring these numbers. So 4 times 4 is 16. And 16 plus 16 is 32. So the left-hand side turned out to be 32. If the right-hand side is 32, it's a right triangle because the Pythagorean theorem works. If the right-hand side is not 32, the Pythagorean theorem doesn't work and it's not a right triangle. So I need to square that. And we said in the multiplying radicals lesson that to square means to multiply it by itself. 4 times 4 is 16. Root 2 times root 2 under the radical gives me a root 4. But the square root of 4 is a 2. So I'm doubling 16, which is 32. So the right-hand side is 32. Since I got a true statement, 32 does in fact equal 32, then the answer, is it a right triangle, is definitely a yes. And the reason is the Pythagorean theorem works, which is what my work is showing. So number 6 is really similar. I have these side lengths. Does the Pythagorean theorem work? So if I ask what number is bigger, 5 root 2, 5 root 2, or 10, well then clearly 10 is going to have to be the biggest because 5 root 2 and 5 root 2 are the exact same number. Specifically, if I put that in my calculator, I'm going to get 7.7 for these two. 7.07, and 10. So the 10 is the biggest number. So the 10 goes in for C. I'm going to square my 5 root 2's, the potential legs. And I'm going to see, does it equal 10 squared? I'm going to start with the easy side. 10 squared is 100. If the left-hand side equals 100, then I know we have a right triangle. So I need to do my work to square 5 root 2. I'm going to multiply it by itself. So I'm going to multiply the coefficients. 5 times 5 is 25. Root 2 times root 2 is root 4. So 25 times 2, because the square root of 4 is a regular 2, gets me 50. So 5 root 2 squared is 50, plus 5 root 2 squared, so plus another 50, which happens to be 100. Again, if both sides turn out to be equal, then yes, you have a right triangle. If you would have 100 equals 101, then no, it would not be a right triangle. But the Pythagorean theorem is your test for whether or not you've